My name is Andreas Stieger. I'm with the SUSE security team. And with me is my colleague
Alexander Bergmann.
Also
from the security team.
And today we're going to talk about the security certifications that we have for the SUSE products and the work we're doing around there. We have the security team has a split job, so we're doing the security maintenance and analysis of our products, but we also like to equip our customers to operate our products in certain requirements with certification environments with certification requirements. And this may include some federal organizations and military customers. Hey, here we go. So we'd like to share some key messages. Some of these you may already know. We're going to start off with the common criteria certificate that we have. So basically the message is SLES 12 is certified to common criteria standards. But just briefly explain what this is. So this is based on international standards and also accepted in many countries. How this basically works is that an independent auditing organization will investigate both the product and as well as the development process and perform their auditing activities. This can be done at a different assurance level. If this says anything to you, the common criteria certification that we've done for SLES 12, as well as the development process is at level EL4, which is quite intense to perform. The certificate is issued by a government agency, and in this case, this is done by the BSI, the German Federal Institute for IT Security. Again, the important thing to note here is that this is mutually recognized with other organizations in other countries. This doesn't only cover technical items and requirements, but also involves the whole development process, such as access to the office facilities and certain requirements of how many people you need to actually get a piece of code into the product. Just an example, it actually needs three people to check something into the code base and to make it into the final product, and this is the same for a maintenance update. So it needs a developer, a maintenance coordinator, this would be our role, and also an independent third party from a totally separate team. So no single person can deliver code to our customers. There's always more than one person involved. The protection profile for the common criteria certificate was the 2.0, and we've included certain rules that we found were in high demand. So this included advanced management capabilities, auditing, and also virtualization. As I mentioned already maintenance. The flaw remediation is part of this, was part of this process. So we have a very well-defined method to deliver maintenance and security updates to our customers. Again, with the same requirements of several people checking them and technical security measures of separation of development workstations from build systems and so on. Again, EL4 with mutual recognition. The platform on which this is currently covered is the 64-bit Intel platform, and for both on Intel and AMD hardware, and the IBM S390X. Due to the specificalities of common criteria, this affects a particular certification target, so it's a particular hardware model, but on which this was achieved. However, by extension, would of course be beneficial to all other hardware models. We've implemented the virtualization with KVM in this case, and this was the item or the method that we looked at in virtualization. This was actually the first time that SE Linux was employed to separate virtual machines. As you may know, a challenge that, and this is the same challenge that appeared when you had multiple users on one host, then you had multiple virtual machines, is to separate users that you may not really trust, the one user's virtual machine from another user's virtual machine. Certainly what we see, we see the same vulnerabilities of crossing security boundaries in virtualization, and we will see the same things in containerized applications as well. So SE Linux is one way to mitigate the effect that some of these vulnerabilities in the virtualization software may have, just to have an additional layer of security to really separate one virtual machine from the host and also from the other machines. We've included our BOV92129 file system that supports a full system rollback and also a full disk encryption scenario. And further, for specific applications, auditing using auditd, IPsec implementation, and SSH. So all of this is available in a particular ISO that we've made available for download. In this case, this also includes FIPS module, and this is the target of evaluation that was used for this particular procedure. Now, if you wanted to put your installation into a common criteria compliant state, you would start with this installation or base your deployment on the AutoYAS profiles that we've used to create this particular image. So this will give you a way to run your appliance or your installation in a common criteria certified way, either using the automation that we have provided for the installation or basing your deployment on the image. And by extension, you still benefit from a particular configuration of a maintenance and product engineering workflow that we've implemented in our company. I'd like to move on to a federal standard, FIPS 140-2, US federal one. Just as an explanation, Federal Information Processing Standards mandated or maintained by the US government agencies, by NIST special publication 800 series of documents, and required by the federal government as well as, or to some degree, the financial industry. And in the US, these certificates are issued by NIST. So just in general, FIPS 140-2 is all about the implementation of cryptographic algorithms and hashes and other cryptographic fundamental operations to make sure that they are implemented following a particular standard. They must contain no known obvious cryptographic weaknesses, and also it is concerned with disabling outdated algorithms and hashes and mandating certain key lengths. The implementation also includes that any cryptographic module, for example, the OpenSSL engine, will perform a self-check on its own hash value, and as well perform certain consistency checks on its own cryptographic fundamentals to make sure that certain test vectors still work as they did when this was validated in this way. And this is to happen before the cryptographic module performs any cryptographic operation whatsoever. I can help you. You're not getting any sound. Okay. Sure. We'll stick around with questions to the end. Yeah.
Yeah, I think it's.
Do I have to start again?
You come back later after we're done.
Okay. Okay, so the current status is that SLES 12 in its original version was FIPS 140-2 validated on the x86-64 platform. We've done this for a couple of cryptographic modules. This includes the kernel, OpenSSL, and OpenSSH, both in the client and the server role. Mozilla NSS, Strong Swan for IPsec, and libgcrypt in the role for disk encryption. Here, Mozilla NSS includes mod NSS for Apache HTTP TLS connections, and OpenSSL, of course, also includes mod SSL for TLS connections on the Apache side. You can actually, if you're on SP1, run that product with the original validated packages from the certificate. We've made this available in the certification module. One peculiarity of FIPS is that it validates a particular binary state. So it's not on the source code. You produce a binary and that is validated. That also means that any other binary that we might produce, such as we do for maintenance and security updates, is not actually FIPS validated. Now, in the strictest sense, there's only one version ever that you can run, and these are the ones that we've provided in the security module. If you are in an environment where FIPS is a requirement, you will have to ask, do we have to run the FIPS validated binaries? Then that's the way to go. I will show you on the next slide. Otherwise, the customer might be happy with just FIPS behavior that is not validated. And we support actually both methods. And you can see the idea of modules and validating a particular state comes from hardware modules that don't change so often. Yeah. I'll show you on the next slide. That's really what is explained here. To put your system into FIPS mode, it's really well, it is easy to do. We have a pattern called FIPS, and you install it, and you boot the system with FIPS = 1 in the kernel command line. This will then trigger behavior in the kernel and all the other packages that I've mentioned of before loading to verify the hash, its own hashes, and to perform self-tests. Oh, it does actually delay the boot for a bit, but yes, they will perform these tests. And you can check this with this kernel parameter. Now, this works in every version of SLES, including SLES 2, which is not yet FIPS validated. So there's this implementation of FIPS behavior, which will be activated in this way. And there's running the FIPS certified binaries, which is only one of these many that we've put out. You can actually force the use of FIPS 140-2 validated binaries. These are available in the certifications module, and it's the pattern certification FIPS. And this will downgrade the packages to particular versions that are frozen in time. Again, keep in mind that there have been vulnerabilities that we've updated after. And this is the NIST is, and also other government organizations are very well aware that this is happening. There's always a conflict between running the latest binaries, which are not validated, against actually being protected against subsequent security flaws. So on FIPS going forward, we, SUSE and the security team, we are actually revalidating SLES 12 SP2, which has just been released, to the standard. So we'll take the binaries that have been produced as part of SP2, and we're putting them through this process again. And what is new also is that we're adding the IBM System-Z platform as a second hardware platform to this. And the expected time for this to be available is mid-2017, so middle of next year. The first might arrive earlier, but around that time we hope to have a decent set available for implementations that require this particular standard. These will then also be made and frozen in the certifications, made available and frozen in the certifications module for usage going forward. As an additional technical measure, we hope to maintain, we will maintain compatibility for running this on SP3, which will come out later. So the FIPS validated binaries will work with the SP3 as well.
Sorry, if you only came this in mid-2017, will that be then on the latest SP2 with patches, or will it be the original SP2?
There will be some version, some maintenance updates. We will make a particular cut when we put these into the validation. So it will be, if we've done maintenance update up to this point, the latest maintenance update up to then, but there will be subsequent ones. So we intend to keep the product FIPS validated. This is always a question of cost and demand, but we see very high or demanding requirements in this area. So, and the third item I would like to talk about today is a DISA STIG. DISA STIG is, or DISA is the, within the US Department of Defense, taking care of information security. And they have implemented a system of, well, essentially these are guides to allow field users to implement or to configure their system in a secure fashion. And you have to have a fairly well-trained, but otherwise normal person. You have to have them in mind, and you give them a security requirement and very clear instructions. Go to this file, check the setting. If this setting is a particular value, that is a finding, and you have to fix it, and then you will give them a particular step to remediate the setting. So it's a hardening guide written with field usage in mind. Now that is the original concept. So it's about creating a secure configuration for particular systems based on a set of requirements mandated by DISA. Once these are collected in a STIG, and once these are published by DISA, these are actually mandatory by use for any use within the Department of Defense. So the current status is that SUSE is developing STIGs for the SLES 12 product. We are doing this for 2 security requirement guides. Thank you. One of them is for the general purpose operating system role. This is kind of the base. And the other role we've chosen is for the web server, use it as a web server. The status is just now is that the content is complete. And we have this submitted this to DISA for verification. DISA is currently writing the test plans and making some corrections, and we've gotten some comments back from the tech editors with minor corrections. That based on the version that we have, there will be some corrections still going in, because obviously this is a very formal process to get the guide into a shape that it does actually work. Every setting is effective, and there's no contradictions in there. So the results of this will be 2 official STIGs, and at this point these will be manual STIGs. So it's documents with this requirement, check this setting, and make this remediation. Now what we would like to do is to put some automation around this, and this will be the next step once these STIGs become official. And maybe in a discussion, we would like to hear some of your requirements. And I've talked to other customers already. Automating this is very high on people's wish list. Now, these can be done in within the SCAP and the overall formats, and we would love to implement this. And this will be our goal going forward. For this, we would like to cooperate with technology partners and the community. And we're strongly considering joining the OpenSCAP project for this, because there's a lot of content already available. And the goal would be to implement exactly the STIG that we have published so far, and any further STIGs that we might choose to develop with automated content. Now, the benefit for customers then will be that this will work with any standard tools, including SUSE Manager and other tools that can read these standard XML files to perform auditing and remediation. And because we can do this internally ourselves, the option exists to produce a SLES media that is pre-STIGged and then can be the foundation for STIG-compatible implementation of appliances and SUSE-based products. And of course, further rules for, say, directory service or secure networking can be included as well. And these will be, as my product will note, based on customer demand and contract value that might be up for that. So the question is it available? Answer, yes, it is. We've put the current engineering status, or the current engineering snapshot, and we've made this available on the FTP server. It's really easy to find within the security folder. Yeah, and so this should give you an idea of how the content will look like. As I said, this is not a version that is approved by DISA, and we still expect some changes before this becomes available. Okay. Good. I think, yeah. With this, I would like to hand over to my colleague, Alexander, who will speak about PCI DSS.
Thank you, Andreas. Okay. Just step over the line. And over here. Hi, everyone, again. Let's talk about PCI DSS. PCI DSS is not a certification of our product itself. It's about, wrong direction. It's about the payment card industry data security standard that's actually used for companies who are processing payment card data. And we are trying to give our customers something on hand how they can actually achieve this kind of evaluation from the PCI DSS standard. It's actually valid for all entities who are processing credit card data in any kind of way. It's standardized by all major credit card companies. It came out beginning of 2004, but there were a couple of other projects, certifications beforehand, but they now combined their forces to have just one particular standard where everyone is working also on. So if something happens, they know this particular security scenario is affecting us, they're putting it into this guide. Right now, half a year ago, the version 3.2 came out, and they adjusted also just small bits of it. For example, I think the 3.2, they got the two-factor authentication mandatory for some kind of scenarios. So it's really like an on-moving process, what they put into this standard. High-level view on PCI DSS is actually, it's quite a big picture what they are drawing. Most of the stuff is formal processes and documentation, but also hardening of systems and the environment that the systems are running in. The areas, we have 6 objective areas and 12 sub-requirements. As you can see here, it's about the network and system security, the cardholder data, that's actually what it's all about. That needs protection, maintaining the systems in a secure state, implementing an access control so that only people that are allowed to work on this data have actually access, monitoring the systems, and testing the network and maintaining an information security policy. The subsections are more graduate, so I haven't put them in here, but they will show up in the regular PCI DSS standard. The essential part of PCI DSS is really the cardholder data. We have two types of data here. The cardholder data itself can be stored from the merchant who is processing the data, but the sensitive authentication data can never be stored. So it's really clear on this that any kind of tracking data or this kind of PIN numbers that you have on your card can never be stored. The PAN, the primary account number, is special because it has to be stored somehow encrypted into the system. But the guide is not really particular how it has to be encrypted. It's more, as I said before, a bit broad about this. So it could a bit depend on the auditor who is actually evaluating the system. Jumping into the requirements and how SUSE can help to fulfill these requirements from the system side. First requirement is maintaining a firewall configuration and a proper system setup. You would actually, first of all, identify certain protocols and services that are running on the system. And yeah, we are using the regular Unix, Linux tools for this. And yeah, identifying listening processes, which processes are actually running, which RPMs are installed. Usually, we would recommend to install just the base system in this case and just install the processes or programs that you really need, so you don't have to deinstall anything. Maybe it's even worth looking into the JUICE, the Just Enough Operating System pattern, so you just have a small system putting on a web server and you don't have to worry about anything else there. From the firewall perspective, usually you would have a corporate firewall where you would manage your incoming and outgoing traffic, but you could also do an addition on the system side. We provide IP tables, and there you have everything also on hand, so you can actually limit the traffic from the system side. So if someone is breaking into your system, it's not possible to spread over all your systems in the data center. You can just define, okay, this process or this particular process is just connecting to the database server, for example, or that the SSH port is just listening on a particular interface. There's also just the regular TCP wrapper that's helping you to just have a wide list of systems, and yeah, no other system could actually connect to your system if it's connected somehow to the TCP wrapper. Requirement 3, you see, we jumped one requirement because a couple of the requirements are not that important for system security. It's more like the formal process, as I said before. So we are here at the requirement number 3. The requirement number 3 talks about encrypting the cardholder data. There's not that much we can do from the operating side, but we can encrypt the disk where a particular database or something is running on. So if you have the PAN number, you would actually encrypt it into your database as well. But if someone gets hold onto your hard drive, for example, for whatever reason, it's still full disk encrypted. So there's another protection layer as well. Transmission encryption is also required, especially over public networks. So if you're connecting two data centers to each other, you use usually a VPN tunnel, or if you have a point of sales, for example, then you should use definitely an encrypted HTTPS connection that uses the latest standards. this is actually, the requirement 6 is actually a big thing where SUSE can help you, because we are trying to keep our products safe, and especially keeping an eye on the security issues that are coming in. So if a certain security issue comes into our queue, we will try to fix it as soon as possible and give you an update package that you can directly install. With the SUSE update stack, you can actually identify if a certain package security update is rated low, moderate, or important. So you just can decide, is this just a low issue, we wait for the next maintenance window, or is it important? Maybe we have to install it directly. You can also check for certain CVEs in the system. So if you heard something about, or your boss is mentioning this or that CVE, you can actually check if this is already fixed in the latest update. All these tasks, as Andreas mentioned before, can be automated with SUSE Manager. So if you want to know which CVE is actually not fixed on some of the production systems, you could use Open SUSE Manager to actually identify them and install this particular update directly. We have an overall profile that can also help you to identify certain security risks and check if your system is in an updated state. You would get a report that actually showing you what the system state is about. Restricting cardholder data, the access to the cardholder data. From the system level, we have the traditional Unix permissions, where you can actually divide certain directories into segments, and only certain users can access them. A more graduate way is to use the access control lists, where you have more power to put groups together. The capabilities of the kernel can be used if you have certain processes of that need actually more capabilities as a regular unprivileged user. So it's not necessarily that a certain process has to run as root. It's also possible to give this process certain capabilities so it can fulfill its job. We have the login access with a pluggable authentication module. As mentioned before, the two-way authentication is possible that way, that you have two passwords or passphrase and at the beginning, or a one-time password that can be used, and your regular password afterwards. If you go a couple steps further, then you could use AppArmor or SLENOX to do even more security contamination. AppArmor is quite easy to use. You really can pick one particular application that you want to protect. If you don't want to use to go the whole 9 yards, because SLENOX is a bit more complicated to get done. It's also necessary to track and monitor the access to the system and to the data. There are different ways to do that. You have the advanced intrusion detection environment coming with SUSE Linux Enterprise, where you actually can identify if certain files or configuration got changed. You can do it even over just a particular directory, or and do a comparisons between two states of the system. So if someone changed some configuration, it would even show up there. You can also check the configuration status via machinery or even salt. But a really good thing is the Linux auditing framework in this particular environment. If you want to identify how something how someone got access to particular data, then the auditing framework is really helpful, because it really can cover the way what happened, how a particular user got more access to a different process. And if you store this on a centralized logging server, you can really see in the aftermath of a particular breach what happened and who is responsible and how this can be avoided in the next time. We are working right now, you're almost finished on a PCI DSS guide that is not yet available, but I hope it will be available in the next couple of days, I hope not weeks. Yeah, I hope we will make it available via a blog entry on the SUSE.com page. And if someone gets additional questions, also the security team or me in particular are delighted to get in contact with you. Even if you have questions, then just drop us a line. Or just ask no questions. That would be really helpful. Any questions about Andreas' topics that he covered or about PCI DSS?
I have some questions.
Sure, let's start from the front.
Okay. So I'm not as familiar with a lot of what you've been talking about, but we sell our product, which is SLES 11 based, into financial data centers, and they require common criteria. What I don't know is the certification for common criteria that you're describing, they apply to the SUSE provided software. Any additional software that I provide, my company provides, or third party, does that invalidate the common criteria for that product? Do we have to do that same type of criteria for our software and for the third party software we use?
Okay. If an organization requires common criteria, it may help to have a conversation with them what this really means for them. If it means that you as a system integrator, that's what I assume you're doing, that all the products that go in are common criteria certified, then yes, starting with SLES 12, that would be something. You mentioned it's on SLES 11, so that's something that we haven't covered and is probably going not really on a plan, given that we started with 12. I'm not aware of any rule that adding a piece would invalidate common criteria as such, because the common criteria is valid for a particular base product, and as we have on the EL4 plus, that includes the maintenance process. However, it's very specific how you can achieve a configuration that is identical to the one that was validated. So this extends actually to 2 particular hardware platforms, or 3 actually, one being Intel, one being AMD, and a particular hardware server model. And also starting from the common criteria image that has the configuration built in. So it depends. If you want to claim that the product in general has in some form or another achieved common criteria certification, then it would be good. Otherwise, you would have to claim that you started out with the image that we provided and have changed nothing that would invalidate this, and also the product that you put in hasn't done anything. So it may help to have a conversation with them.
I have a question. Why do you specifically exclude the late service and IBM PCM system, whichever it's called now? Why do you only look at the x86 and the
We're not as such excluding them. We're not including the, yes. The validation cost and effort depends on, so there's no particular reason. There's just the demand that we've seen just now And I mean, you can imagine that there's a particular three-letter company that might be very interested in having this particular item available for the S390 platform. However, we are in a position where we can sort of add this, should demand be, either add this to a current project or to a future one.
No reason other than demand and cost.
Yes.
Internally, you have the same practices for all the architecture internally.
Absolutely, yes.
Still three engineers, whether it's ARM or x86 or.
Yeah, so if I understand, so yes, the maintenance and building is the same. For particular architecture, we may have architecture-specific experts that will make the source run on a particular platform if it doesn't work there yet. If we put out an update for all these supported architectures out there, they're actually built from the same source at the same time. Yeah, so.
Then as far as the DISA requirements go, are you aware of any of the other militaries across the world that also use the same standard?
I'm not actually aware. To my understanding, this is US specific, and maybe some other military organization might have very similar requirements, or for cost effectiveness might just copy these. I'm not aware of any of the others. Maybe, yeah. Jamie is a US federal sales engineer expert. Yes, that's the words.
Okay. So certain militaries do use it when they're in cooperation with the United States. So, like certain joint technology projects use the DISA STIG requirement also because it's required on the American side. Some militaries have turned around and because they know they have something, they may be working with Americans eventually, they do it automatically. I know that a lot of NATO things do use the STIG because of the interoperability with the American computer networks. If you do not apply the DISA STIG, you cannot get an authority to operate on a DoD information network. So.
I'm wondering for the client because none of the African militaries and they use quite a lot of SLES have ever spoken to me about.
Just summarizing for the record, yes, other militaries might implement STIG if they want to cooperate with NATO or the US DoD. Yes, and the South African ones, I can imagine that they wouldn't be in this network. No.
Because they definitely ask FIPS and they definitely ask for the common criteria, but they
yes. That is also one of the challenge from like directing focus from our team. That some of these are very specific, and then you finish them and you turn around and they say, "Oops, but I can't sell to South Africa." However, there's real value in it, and the product management will always like listen to reasonable suggestions there because yeah, it creates values for our customer and also for us these sales opportunities. We don't like to be excluded from any particular opportunity just because we don't have a piece of paper. And also we believe that all of what we're doing, besides creating value to customers, actually makes the product better. Yeah.
The other thing with the STIG is it's starting to be used across the US government now as a standard security baseline, so for US federal government. So it's becoming, some of the financial customers in the US have been coming to me, their engineers have sent them to me because they're starting to ask for the STIG, which is kind of interesting. It's, the idea is kind of almost grown that it's turned into, if we secure our system to this highest level, if anything goes wrong, we've done our due diligence.
All right, so you can claim to be a military strength
Yes.
bank, yes. So, I mean, it doesn't.
It's having implemented a lot of, before I came to SUSE, I was a defense contractor, so it was just part of what we did all the time. It does create a secure system, And I think that's why a lot of people are starting to look at it for non-military systems and non-governmental systems, because it gives them a level of assurance that this has been tested, and it's a very thorough process of DISA to get your STIG through. It's not easy, and
We've added, and this is why we would love to have it here and just put it on the table. Yes, but things, I would consider it not due diligence on their part. We've been working on this for a while, and we've learned a lot, and then we can take from there for both the automation and also extending our footprint on further states.
So regarding the common criteria, does this apply to like packages? Is it the packages that are certified, like, or is it a particular configuration of the software, like you have a patch or something like that? And then can you configure the package in such a way that it's no longer common certified? You know what I'm saying?
Okay, yes. So in the very strictest sense, common criteria applies to the target of evaluation, which is SLES, based on the ISO image that we have available for download, or installed with the particular AutoJust image that is included there. On two particular models of server they can buy, or an IBM Z12 model of mainframe. So yes, because you have to define a target of evaluation, and you pick a particular piece of processor and model. So that would be the common criteria implementation. Yes. That doesn't mean that the certificate itself is not valid in other configurations or on other hardware. Yeah, but you would have to, on the configurations that we do supply, you would have to apply the configurations that we bring with this ISO. You asked about the patching. There's no particular patch level because the flaw remediation is part of the common criteria certifications. So yes, as long as you keep if you are on the maintained path, then that's your common criteria.
So we build our product, we integrate it using the SMT server in Kiwi. We build our own images. Do we still claim that it's common criteria certified?
That's what I'm
trying to understand.
I mean, yeah, because that takes it away from the target of evaluation.
Right.
Yeah.
The common criteria certificate really is for the whole process, from the development, from starting from the sources, from the building, in a secured facility like we have in Nuremberg, to a certain set of packages installed in a certain way. Some customers installed on a certain hardware.
Yeah.
So some customers are accepting that only parts of that, so that they can install on other machines, not just on a 2 or 3 server hardware machines that we have defined, but if you add stuff on top, if you modify the installation, then this target of evaluation is cannot really be claimed anymore.
Yeah. And I'm sure you're aware of the effort and costs that it would bring for this. Yeah, so it's probably, yes, it would be helpful to find out if for your customer it's enough that the foundation on which you base the implementation was at some point common criteria certified.
What our customers generally do is they'll run a penetration test on our appliance, and they're all using different flavors of penetration tests, and sometimes we pass and sometimes we don't. Recently this year we had a customer that had hired what we call like black hat hackers.
Okay.
Hackers, and we put in our lab one of our clients that we firewalled it all off, and they had a whole weekend to break into it, and it didn't take them long. these guys were quite experts in Linux. And it was helpful. I mean, they were trying to protect their customer, but also help us to figure out how we can make our product better. And it wasn't around SUSE software the way we had misconfigured our application. But that's kind of for our space that we're in, that's more what the customers are interested in. Ours, not so much these certifications. Yes, it's important for them to know the base is, but it's more and more these penetration tests.
Okay.
And that's where you might want to do the STIG.
Yeah.
That's what the STIG is designed to do. I mean, at its heart, this is the motivation for developing this, was to create a standard baseline across the Department of Defense for secure computer access. So these are things you don't want people to break into.
Right. But is this more around a liability thing? Like if you claim your STIG, then if something does happen,
so it's a twofold thing, right? So if I don't know about outside the DoD and outside the government, but in the government, it's for the DoD and the intelligence community, it is foundational. If you do not have a STIG, you do not get on the network. Done. Over. Right? The rules have become stronger now due to things like all the security threats they've been facing lately, all the intrusions problems they've had, the OPM breach, all these things have gathered together and made it more restrictive. So the thing about the STIG is, at its heart, it was designed to protect a military computer asset from being penetrated and, having something bad happen because of that. So one of the things it does is it goes through and it closes ports you don't use. One of the things you remove is TCP. Not TCP, Telnet. You remove Telnet because you don't need that. Use TCP IP wrappers is something else. So these were laid down as what DISA has decided is an acceptable baseline between hardening your system and being able to use your system. So that's really what its intention is. Commercially, some customers are starting to use the STIG. I'm getting more and more commercial customer questions about it. Because in some industries like finance or insurance, for them, their idea is if they use it, and if something goes wrong, I mean, there's no indemnity about it, right? Like, DISA doesn't guarantee you're not going to get hacked. That's not how it works, right? But they believe that it gives a level of security that they have really hardened the system as much as they can.
Remember that go up to the point of easiest entry.
Yeah,
So
no,
if your system is more difficult to get into than your neighbor's one, then you're more secure.
I'm really confused. I'm a little bit confused because I know we sell our product into government.
Right.
Some of it's, I don't know currently, but there have been past versions of our product that have gone into I believe into intelligence.
So
That are not, I mean, you can tell from my conversation, we've not done anything particular.
they will, so it all depends. Like, sometimes I would receive a product from another integrator and I would then take it apart and stick it for them because they didn't have the expertise to do it.
It may be that ours, I don't know whether it depends or not, but maybe it's not in a production environment. Maybe in a lab department it's different.
There's slightly different rules, but they're trying to crack down on rules across the board.
Right.
So there are things that were okay that I would have done in my lab 5 years ago that are not okay today.
Right.
There are things I would have done 2 years ago that are not okay today.
Right.
So and that's the thing. It's a shifting target.
Right.
And so there's a lot of different things go along with it. I'm more than happy to have an offline conversation with you about it because we can go on. I don't want to hijack everyone else's time.
Okay. Yeah, actually, time is a good keyword. We are out of time. I'd like to thank you for listening. We'll stick around a bit, and also if you want to catch us, I put out some suggested sessions that are actually up next. One of them is Security Essentials, which is a colleague of mine, Thomas Wiege, and also a particular session on tutorial on SE Linux if you're interested in that. I'd like to thank you for your attention, also on behalf of my colleague Alexander, and wish you a nice remainder of the conference, and maybe see you at the party tonight. Thank you.